here is the next part, and this is curve fitting. So let me draw a distribution again. So let's say this was my stochastic model, and I ran the 10,000 scenarios right here. So there we go. And the question is, like, you could get a pretty good idea of what your mean is. But the problem is, you don't know, like, all of the scenarios here in your tail risk, you don't really know, like, how well that's measuring your tail risk, because there's only a certain number of policies, the scenarios there. There are much fewer than in this distribution right here. At least this is my takeaway on this section. Now, let me just say this right here. The curve fitting, the initial effort required, I think it's just so, one of the things that makes it marked high right there is because out of all 6 of these, this is the one that's the most academically challenging to do, to put in place. If an actuary is only concerned about the mean of their distribution, you wouldn't use curve fitting, because you know the mean, you have a lot of samples there, a lot of scenarios there, so don't worry about it. But if you're concerned about the tail, what you can do is you can find some sort of distribution that mimics your model. Like, let's say it's like the Weibull distribution, and then you get some sort of fit there, and it's a little bit off, but you want to get it to try to like match your tail risk right there, and there you go. You can use the Weibull distribution to try to measure your tail distribution, like your CTE 95, for instance. I could just totally imagine there was a professor at some sort of university. I know they mentioned that there's like a study done at a university or something like that, and I could just imagine the professor was just so excited. He got all his grad students in the stats department and said, we're going to make a huge breakthrough in the insurance industry if we match like all these distributions together, because they're all big on statistical distributions and actuaries don't use those a ton. And so, right, we're going to make this big breakthrough and we're going to find the tail risk. Well, kind of funny thing is, after the project was done and after all the study was all done and said and done with these companies, actually the errors were pretty bad. And so it's all a question on whether this one really works or not, and then the author of this research paper kind of left it up to be continued on whether this would really work or not. And so that's why they said, like, runtime reduction experienced, it's unknown. Again, it's useful for the tail metrics. Bias is a significant concern on what model you decide to use for your tail metric. Again, reading through the paper, it kind of looked like it was pretty bad on the error side of things. And so, it's kind of like the author of this research said, it's up to your discretion on what to use it. You need to have a lot of caution. It could help a ton using these fixed distributions, but just be careful. And honestly, like, I'm not too impressed. If I was reading this paper and I was wanting to implement something, if I saw this one said, it's really hard to use and really high academic and who knows if it'll even work, I'd probably just throw it out. But anyways, this is what curve fitting is. And just to end, I did want to show this little error page right here on this. You can see measuring the CTE 70, the error was higher than measuring the CTE 95. And so in any case, I'm not too impressed by how high the error is, especially for the CTE 70. But then again, maybe it could work really well if you're able to just implement this in rolling forward, and it really could reduce your runtime. But there it is. There is your curve fitting.